All right, so let's start with a bell work problem. You guys have seen these two matrices before. I've used it in a different journal, but I want us to use it to solve this problem here. So you can see there's a -3 times A, and A is the matrix here. And then there's a half times B, where you're going to grab the B matrix. So just to set this up to show you what we're trying to multiply, we have a -3 that's on the outside, and then we have the matrix A, which is -2, 4, 0, 3. And then it looks like I have a plus sign here, 1/2 times matrix B, which is -6, 4, 2, 0. All right, so then what I need to do here is multiply this 3 inside to the matrix, so everything inside the matrix gets multiplied by a 3. So if I do this, this is really going to be -3 times -2 is a +6. -3 times 4 gives me a -12. -3 times 0, just a 0, and last but not least, -3 times 3 gives me a -9. And I'm going to add this to this matrix after I multiply by the half. Now, I like to think of half as 0.15 if I'm going to try to do this in the calculator. Or, like, if you're multiplying by half, basically you're halving all of these numbers. In other words, like, if you multiply half to this -6, half of -6 here is, oh, where's my pointer? There it is. Half of -6 here would be -3. So this would be a -3. Half of 2 would be 1. Half of 4 would be 2. And half of 0, well, that's just 0. You half nothing, you get nothing. That's how I like to think of it. So then these two matrices are both 2 by 2s, right? And if they're both the same size, kudos for you, you can add the matrix by adding the corresponding side. So you're going to make another 2 by 2, and I'm going to take the numbers corresponding and add them together. So 6 plus -3, +3. -12 plus 1, -11. And 0 plus 2, just a 2. -3 plus 0 is a negative. Sorry, did I say -3? -9 plus 0, -9 here. And then that's it. I have simplified my matrix, and this would be the final matrix that I have left. All right, so in this lesson here, I'm going to talk to you about multiplying matrices. And to multiply matrices, you're going to take basically the matrix and figure out the dimensions. It's really important that you figure out the dimension or the size of the matrix first, because what you need to check for is the inner numbers. So the inner numbers, or the inner dimension, is basically when you get the first matrix size, you're going to look in its columns, and you're going to look in the row of the second matrix. And if those two numbers match, then you can say that you can multiply. So basically, the inner dimension is what I refer to it, needs to match in order to multiply. If they don't match, then it's going to be undefined. And then the outer, here's the cool part. If you know that the inners match, the outer is going to be the resulting matrix side. So this will be the result size or dimension. In other words, your new matrix after you multiply is relative to those numbers that are on the outside, will be the dimension that the new matrix will be. So you have to figure out the size first before you can determine if you can multiply. Also, another thing, when you multiply, you always take the first matrices rows, and you always use the second matrix's columns. And you will always multiply rows by columns. So always rows, then columns. And I'll show you what I mean in the next slide to kind of show you an example. All right, so here's the optional homework. We're going to do 4 of them together, and then I'll give you the exit ticket problem for you guys to try on your own if you want that extra point for today. So just starting us off, we have a 2 row, 2 column. So this is what I refer to as a 2 by 2. I don't know about you, but it really helps me when I see this as a grid. So I like to cut this as a grid, and so then I can really see that there are 2 rows, 2 columns, so this is a 2 by 2. And then this matrix here looks like 2 rows. Like if I were to cut this in half, you can see that that is 2 rows and just 1 column, because that's only 1 vertical line of numbers. So this is a 2 by 1. And so I need to check the inner dimension. The inner dimensions are both 2's, which is good, so they match. That means you can multiply this, but remember what I said, that the outside dimensions will act as your new matrix size. So after we multiply these 2 matrices, we're going to get a 2 by 1. So I'm going to draw my new matrix. I'm going to exaggerate the size just a little bit so I have room to work inside the matrix to show my work. And like I said, this is going to be a 2 by 1. So what I'm going to do is cut this matrix into a 2 by 1 and make a grid. You don't have to do this part. I like to do it so I know which ones to multiply. You'll see what I mean when I actually multiply. So this is a 2 by 1. That means I need to cut this in half horizontally. So I have 1 row, 2 row, and this is 1 column. So this acts as 1 column. All right, then from here, what I'm going to do is if I want this piece right here, this is the first row and first column. So I'm going to take the first row, and like I said, you always want to use the rows from this matrix and the columns from the other matrix. So I'm going to take the first row. Oh, that's kind of small. Let me make that a little bit thicker. There we go. I'm going to take the first row and multiply it by the first column. And when I do this, here's the thing, is what's going to happen. I'm going to take the first number in this row and multiply it by the first number in this column. So 1 times -1 is -1. And then you're always going to add the next product. So what I mean by this is you're going to take the second number from this row and multiply by the second number in this column. So 2 times 7 gives me 14. Ooh, let me do that in corresponding color, 14. All right. And then in this bottom one here, notice this is the second row, right? So now I'm done using this column for this first row. I'm going to now have to move to the second row and multiply it with that column. So looking at this here, we're going to take the first number in this row, multiply by the first number in this column to get -3, right? 3 times -1 is -3. And then I'm going to add, because we always add after, and multiply the second number in this row with the second number in this column. So 4 times 7 gives me 28. All right, looking at this, I'm just going to clean up a few things. This time I'm not going to use a grid because I can see, what number should be in each space. So again, this is going to be a 2 by 1. -1 plus 14 gives me 13 for the top. And then for the bottom here, -3 plus 28 gives me 25. So this is our matrix. I've already simplified everything. And like I said, this is a 2 by 1, so I should have 2 numbers inside. And I do. So this is my final answer. All right, let's move on to this one here. So this one, let's take a closer look on, the grid here. So this looks like 2 rows, right? 2 rows, and 1, 2, 3, 4, looks like 4 columns to me. Let me do this using my highlighter. So I can definitely see 2 rows and 4 columns. This next one here looks like it has 2 rows as well and 2 columns. 2 rows, 2 columns. So this is a 2 by 2. Sorry, I'm trying to grab my pen. Okay, so looking at the middle, right, the inner dimensions do not match. If they don't match, then that means you cannot multiply. So if you can't multiply, then this matrix here is actually undefined. So we check the inner dimensions. They were not the same, so I can't multiply, so I'm done. I just call it undefined. So make sure you do check the size. It can save you a lot of time if you do. All right, let's try 2 more problems and then we'll hit the exit ticket. Okay, so this first one here, they're both a 2 by 2, right? So in this case, this one has 2 rows, 2 columns, 2 rows, 2 columns. So we can see that the inners do match, which is good. That means you can multiply. And the outers is a 2 and a 2. So when I multiply this, this will happen to give me another 2 by 2. And again, I'm going to make this matrix just really big, just to make it easier for me to show my work. So again, this is going to give me a 2 by 2, and I'm going to make a grid. You don't have to. I just like to see this boxing so I know which where to put the number when I multiply. Okay, so in this first corner here, notice how this corner here is the first row and the first column. This is the first row and the first column. So you're going to grab always the rows from this matrix and the columns from this one. So I'm going to take the first row in this matrix and multiply it by the first column. And when I do that, this is going to be the first number here, the first number in this row, times the first number in this column. So 5 times 3, 15. Plus the second number in this row times the second number in this column. So 2 times 1 gives me a 2. Oops, sorry, I meant to use my highlighter. 2. Okay, and then the next number here. So if I want to figure out what goes here, notice this is still the first row. So I still want to use this row, but this is the second column. So I don't want to multiply with this first column anymore. I want to use the second column. So again, I'm going to take this row and multiply by this column. So 5 times negative 2 is negative 10, plus 2 times 0 is 0. And then I'm going to multiply the second row with the first column. Because notice how I'm needing this box right here, which is the second row but first column. So I'm going to multiply the second row with the first column. So negative 1 times 3 gives me negative 3, plus 4 times 1 is 4. And last but not least, this is the second row with the second column. So I'm going to take this second row and multiply it by this second column. So first number times the first number, negative 2 times negative 2 gives me a positive 2, plus 4 times 0 gives me a 0. So if I just clean up my matrix here to simplify, 15 plus 2 gives me 17. Negative 10 plus 0 is negative 10. The bottom here, negative 3 plus 4 gives me a 1. 2 plus 0 is just a 2. And so there is my final answer for this matrix here. And I'll just highlight that. And that's it. So, like I said, check the dimension. Inners need a match. Outer tells you the resulting matrix, and then you always multiply rows by its columns. All right, let's do our last one here. This one here looks like we have a, let me grab my pen here. Looks like 2 rows, 1 and 2, and then 1, 2, 3, 3 columns. Oops, let me do that in a highlighter. And then it looks like this one here, so again, this one is a 2 by 3, and then this one looks like 1, 2, 3, 3 rows, 1, 2, 3, and then 2 columns. So if that's the case, this is really a 3 by 2. Well, since this is a 3 by 2, the inners do match, so that's good, right? They're both 3s, so that means you can multiply. The outer here looks like a 2 by 2. So you're going to be producing a 2 by 2 here. So let me set this up. I'm going to make this another big matrix. And this is going to be a 2 by 2. Which is really interesting because both of these matrices are way bigger than a 2 by 2, right? This one can fit 6 items inside, but a 2 by 2 only can fit 4. So it's interesting to multiply 2 big things to make a small thing. At least for me it is. So like I said, I like to make a grid, so I'm going to make this here into 2 rows and 2 columns. So 2 rows, 2 columns. And I'm going to figure out what goes in the first box. Now again, this is the first row, first column. So I'm going to take the first row and first column and multiply. So I'm going to make the first row times the first column. And this is going to be first number times the first number. So 2 times 0 is 0, plus second number times second number. So 2 times -1 is -2, plus -1 times 0 is just 0. And that's our first number that will go in the box. Now in this box, this is the first row but second column. So I'm going to take, again, the first row but now with the second column. So this is 2 times 2, because the first number times the first number gives us 4, plus 2 times 4, the second numbers multiplied will give me 8, plus the third number times the third number, so -1 times 2, gives me -2. All right, now I got the top. Notice I need the second row now, so I don't need this row, I need the bottom one. So I'm going to grab my highlighter and take this row, multiply by this column. So 3 times 0, just 0, plus 0 times -1 is going to give me 0 again, plus the third number times the third number, so 1 times 0, another 0. So they all end up being zeros. That's fine. And then we're going to take this row again and multiply it by the last column, the second column, to get the number that goes in here. So first number times the first number, so 3 times 2 is 6, plus 0 times 4 is 0, plus 1 times 2 is +2. So if I were to clean this up here, it looks like in my matrix I have 0 plus -2 plus 0 is a -2. 4 plus 8 is 12, plus a -2 gives me a 10. These are all zeros being added, so that's just going to be 0. 6 plus 2 is 8. And then that is pretty much all I can do here. So this is my final answer. All right, guys. So if you're feeling pretty good about these past 4 problems, check out the next slide here, which is the exit ticket problem. So here it is. You're taking these two matrices. They're both a 2x2. So you guys know that, well, if it's a 2x2, you're definitely going to be able to multiply since the inners do already match because they're the same. So when you multiply this, see what is your new matrix. And then once you get your answer and you think this is the correct answer, come to me and I'll give you a stamp for that point. Anyhow, I hope you guys found this video helpful. Until next time, guys. Bye.